Hello everyone, welcome to Maths Bridge. We try and learn. Today we shall together explore object-oriented programming fundamentals. Let's get started. In today's agenda, we will go through need of good software design, what is meant by a programming language, types of programming languages, why many programming languages exist, procedure-oriented programming language, object-oriented programming language, hoops, building blocks, procedure-oriented versus like object-oriented programming languages, OOAD at a high level. Let's get started. What is the need of a good software design? In today's world, almost we are building a software solutions for every possible real world problems. So a good design leads a good system. So what exactly we are looking at? We need a good software design to represent a correspondence between a software and a real world problems. To design system with open interfaces. To ensure reusability, extensibility of modules. To develop modules to accommodate any change in the future. To improve software productivity, to improve the quality of the software. Make a point. Design is not a coding and coding is not a design. So if you have a proper design in place, then you should be able to build, meaning develop a system using that design. There are the few characteristics of the good software design. With respect to operations, we need a correctness, efficiency, integrity, reliability, security, safety, and usability. With respect to transition, we need a portability, prototyping, transferability. With respect to revisions, code reusability, extensibility, flexibility, maintainability, modularity, scalability, and testability. Programming languages. When we spoke about a software engineering or the software, the first thing that comes in your mind is programming languages. What is meant by programming language in general? A programming language is defined by syntax and semantics. Syntax means the valid statements in that language. It validates the statement, right? Semantics means what those statements do. A programming languages can be compiled or interpreted. Compile means whole program translated into machine language. Interpreted, on the other hand, individual program statements translated as needed. Machine independence achieved formally by standards and IEEE implemented in practice by intermediate language like a bytecode, for example, Java. Types of programming languages. We have three different types of programming languages: low level, medium level, high level. Low level means a machine code which runs on the hardware platform. Medium level, one level above the low level language, which is assembly language. Finally, we have high level language, which is language like a natural language. Under high level, we have a procedure-oriented programming languages, object-oriented programming languages. We shall see more in detail about object-oriented programming language. We discussed in brief a need of good software design, different programming languages, and there may be many languages under each category. The question here, why so many languages exist? Why so many languages are designed for? Right? The answer would be programming languages are designed for different tasks. for instance, Proton for scientific computation, COBOL for business applications, HTML, CSS, JavaScript, React.js are for front-end web development, JavaScript, TypeScript, Python, Go are for back-end web development, SQL for database creation. Similarly, programming languages are designed for a different way of thinking. In the real-time problems, in the real-world problem scenarios, we are trying to solve them using different way of thinking, a procedure-oriented, objective-oriented, logical programming, and script-based programming. We shall see more in detail procedure-oriented versus objective-oriented programming languages, the benefit of leveraging objective-oriented concepts more in software design. Let's look at a procedure-oriented programming. In procedure-oriented programming, the large programs are divided into smaller programs known as functions. Let's look at this, a main program which is of a large program, for instance, that further subdivided into multiple functions. A functions may have inner subfunctions. It emphasizes more on doing things like building an algorithms. The procedure-oriented programming follows a top-down approach. It does not have any access specifier to access the data. Data can move freely from one function to another function. Most of the functions uses a global data for sharing that can be accessed freely from function to function in the system. It does not have a proper way of hiding data, so less secure. Any function can manipulate the data. Let's look at object-oriented programming in short. We also known as OOPS. OOPS means object-oriented programming. OOPS follows bottom-up approach in program design. OOPS treats data as a critical element in the development of program. It binds the data more closely to the functions that operates on it. Programs are divided into what are known as objects. Data is hidden and cannot be accessed by external functions. Objects can be communicate each other through functions. New data or new functions can be easily added on need basis to existing programs. OOP is faster, easier to execute. It provides a clear structure for the programs. Don't repeat yourself. What does that mean? Makes code easier to maintain, modify, and debug. Repeatability is always not encouraged to use. So let's avoid duplication of the code in the programming development, which is where OOP supports. Let's take a look at difference between procedure-oriented versus object-oriented programming languages. The procedure-oriented programming language, in which the program is divided into a small parts called functions. It gives more importance to functions rather than data. It follows top-down approach. It does not have any access specifiers. To add new data or functions to the existing program is not easy in procedure-oriented programming. Most of the functions uses global data for sharing that can be accessed freely from function to function in the system. In a way, this is one of the disadvantages. Let's look at now object-oriented programming. The program is divided into parts called collaborative objects in object-oriented programming. Here, the importance is given to the data rather than procedures or functions because it works as a real world. Hoops follows bottom-up approach. Hoops has a access specifiers called public, private, protected. Hoops provides an easy way to add a new data and functions. In Hoop, data cannot move easily from function to function. It can be kept public or private so we can control the access of data. What do you mean by analysis, design, and programming? In object-oriented world, we have analysis phase, design phase, and programming phase. In analysis, we have to question ourselves, what do we need to do with respect to the system that we are going to design? In the design phase, we have to ask ourselves, what are we going to do to build a system, right? In the programming phase, we build a solution. In object-oriented programming, the few things that we need to remember, primarily, gathering the requirements, describe the functionality of an application, detailed out non-functionality of the application, identify main objects of an application, define interactions among objects, started creating a class diagrams, and so on. OOPS concepts, object-oriented programming concepts. Object-oriented programming is a programming paradigm or pattern of programming based on concept of objects. The solution to a problem is modeled as a collection of collaborating objects. Objects can contain data and code. Data in the form of field, like an attributes. Code in the form of procedures, methods, functions. A common feature of objects is that methods are attached to data and can access and modify the object's data fields. Object-oriented programming is most suitable for managing large complex problems. In OOPS, we have concepts like objects, classes, data abstraction, encapsulation, inheritance, polymorphism, dynamic binding, message passing.
Thanks for watching. Please like, share, subscribe, click on the bell icon, and please leave the comment. Happy learning. Thank you. Stay tuned to the upcoming sessions.